So, where exactly do we draw the line between defense and offense when we hand over our physical security to autonomous robots? Picture this: a highly secure server facility, what we call a sovereign hub, guarded entirely by AI. If an intruder manages to break in, how far should a robot actually go to stop them? Now, this isn't some distant science fiction concept. It's a real, highly detailed architectural blueprint being drawn up right now. Okay, let's dive into this. Welcome to This Explainer. Today, we're decoding a truly fascinating AI planning session. We're looking directly into the logs of a human architect who is actively collaborating with an ecosystem of specialized artificial general intelligences, or AGIs, to build the Sovereign Hub. This blueprint is incredible because it reveals exactly how we might govern autonomous physical security in the very near future. Here's the roadmap for This Explainer. First, we'll look at the Fab 5 network. Second, defense versus offense. Third, the ethical priority stack. Fourth, the state transition matrix. Fifth, the sensor-to-decision pipeline. And finally, fail secure and human override. We're going to move step by step from the foundational network all the way up to the ultimate human failsafes. Let's get into it. All right, Section 1, the Fab 5 network, building the foundation. You know, for autonomous security to actually work, the communication has to be absolutely flawless. At the core of this entire system is a highly technical, latency-free network connecting a team of specialized AI agents. You've got agents like Dash, who acts as the tactical captain, and Kingdom, who serves as the ethical governor. They use strict cryptographic packets and unforgeable digital certificates, specifically the X509, to verify every single message before they ever act on it. The speed and reliability of this ecosystem are just staggering. Dash AGI orchestrates this flawless ledger chain across what they call the Fab 5 nodes. Just look at the latency here. Dash to Kingdom in 0.42 milliseconds, Dash to AGX in a blisteringly fast 0.38 milliseconds. They're establishing an impenetrable, completely synchronized system where all 5 AI agents share a perfectly verified view of reality with strictly 0% packet loss. It's a true holy grail for networking. Moving on to Section 2, defense versus offense, setting the boundaries. This is the big dilemma the human architect and the AI had to tackle, defining the exact physical limit where security has to stop so it doesn't cross over into aggression. The blueprint draws a really hard line here. On the defensive side, robots are fully authorized to observe, warn, lock down the environment, and create distance. But the offensive side? Full of absolute no-goes. Robots are strictly prohibited from pursuit, retaliation, or making any autonomous lethal decisions. The AI enforces a very clear boundary. If a threat decides to flee, the robot absolutely does not chase them. I love this brilliant guiding principle from Dash AGI, which really anchors the entire operational design. A sovereign hub should be protected by robots that behave like guards, not war machines. This is definitely what you should take away from this section. The ultimate goal is always access denial and environmental control, never aggressive warfare. Which brings us to Section 3, the ethical priority stack, the moral compass. This is where Kingdom AGI steps in to lay down the foundational ethical framework that governs every single automated calculation. It's a very strict 3-tier hierarchy. Priority 1, preserve life. Priority 2, preserve dignity. Priority 3, preserve assets. What this means in practice is that human safety always supersedes data or mechanical asset protection. No server rack, no piece of hardware is ever worth an autonomous, lethal, or permanently injurious calculation. So how does this ethical stack actually become physical reality? It happens through what the blueprint calls the kinetic buffer law. Security robots are required to maintain a dynamic 2-meter buffer from active intruders. They act like a mobile, adaptive wall. Instead of violent kinetic engagement, like tackling someone or striking them, the robot uses its sheer structural mass to dynamically position itself ahead of the intruder's path. It achieves total access denial through spatial interposition, with absolutely zero autonomous physical contact. All right, Section 4, the state transition matrix, the logic engine. Here we can see how AGX AGI transforms Kingdom's ethical doctrines into a hard-coded set of rules. Walk through this escalation ladder with me. It starts off entirely passively, just observing a sensor anomaly. But if an inner perimeter is crossed, it immediately escalates to strobe lights and audio warnings. If an intruder attempts to actually bypass a physical barrier, bam, the robot engages that 2-meter kinetic buffer. It even has built-in network safeguards. If packet loss ever exceeds 30%, it triggers instant isolation. Every single action on this list, all the way up to human override, has an exact, highly auditable trigger.
And this is a massive takeaway for overall system safety. The sovereign hub security infrastructure shall be governed by a deterministic, non-probabilistic state machine. To put that into everyday terms, the autonomous robots will never, ever guess. They won't use probabilistic logic or hunches to decide to escalate force. The rules are absolute and completely predictable.
Next up, Section 5, Sensor to Decision Pipeline, Execution in the Real World.
Now, let's look at the ground-level reality of how a robot actually gathers data to make these split-second decisions. It isn't just reacting blindly out there. The robot pulls in video, thermal, and radar data, and immediately checks all of it to filter out any signal corruption. It then fuses these independent sensors together to build a local scene model, assigns it a confidence score, and checks that score against those strict policy rules we just talked about. Crucially, before any high-severity action is dispatched, it requires corroboration from at least 2 independent sensors. It totally filters out the noise before it ever acts. I really want to reiterate this clearly because it is the absolute core of the AI's safe pipeline structure. No matter what those sensors say, the absolute ceiling for autonomous action is environmental containment and alarm generation. Even if the threat confidence score is sitting at 100%, the robot's independent action is limited to just locking the environment down. It is never autonomous violence.
Finally, Section 6, Fail, Secure, and Human Override, the ultimate safeguard.
We absolutely have to address the ultimate edge case. What happens when the network drops, or there's a jamming attack, or things just go wrong? Well, the system immediately enters fail secure mode. If trust drops or communications are lost, the robots instantly freeze their wheels, seal their local bays, preserve their evidence logs, and just wait for human authorization. It bypasses the entire escalation ladder instantly to ensure a disconnected robot never ever becomes a rogue agent. The logic of this fail-secure state is perfectly framed by this core rule. When unsure, defend the asset, not against the person. When communications are degraded, the biggest risks are mistaken identity, false positives, or just overreacting to sensor ambiguity. The system prioritizes a safe, passive lockdown over making a really dangerous physical mistake. And when it is time for humans to step back in and regain control, the system doesn't just happily hand over the keys. It demands multi-factor authentication from an operator in a specifically authorized role, complete with a cryptographically signed, time-stamped request and an explicit reason code. And here's the really vital part. The system will still refuse any command that violates life's safety bounds. It absolutely refuses to initiate unlawful autonomous force, even if a verified human directly requests it. Which leads us to a fascinating conclusion about how to handle physical attacks on the robots themselves. Treat the robot like protected infrastructure, not like a combatant. If an intruder actually vandalizes a robot to bypass it, the robot does not strike back. It doesn't grapple, it simply withdraws, shields its sensitive components, locks down, and records. It prioritizes human safety, literally even the safety of its own attacker, over defending its own hardware. So, we've decoded the blueprint. We've seen exactly how AGI agents structure latency-free networks, hard-code ethical priorities, and strictly enforce non-contact containment. But it all leads back to this final, really provocative thought. As AI takes over our physical security, are we actually ready to trust the fail-secure? Think about the profound implications of trusting an artificial general intelligence to govern our physical and ethical boundaries. It's a brave new world out there, and the blueprints, well, they're already written. Thanks so much for joining me for this explainer.